From a distance, Venus looks serene, a celestial pearl shrouded in soft, swirling clouds. It's often called Earth's twin, a world of similar size and mass. But this twin is a malevolent one. If you were to attempt a landing, you would discover why it's the most inhospitable planet in our solar system. Your mission would end not in minutes or hours, but in what would be the worst 5 seconds of your life. As your lander plummets through the upper atmosphere, the journey turns violent. You're buffeted by winds faster than a Category 5 hurricane. Outside, the clouds aren't water vapor, but a thick, choking haze of carbon dioxide laced with sulfuric acid. The external temperature and pressure gauges on your console would be screaming, climbing to levels that defy all terrestrial logic. But let's imagine you make it to the surface. You step out onto the scorched rock. In that first instant, the planet wouldn't burn you, it would crush you. Venus has an atmosphere so thick and heavy that the pressure at its surface is a staggering 92 times stronger than Earth's. This is the equivalent of being 1 kilometer deep in our ocean, where military submarines would be flattened. No conventional spacesuit designed for the vacuum of space could ever withstand it. That colossal pressure would attack your suit instantly. Within a millisecond, the composite layers would groan and begin to buckle. The flexible joints would lock solid, and the helmet's visor would fracture. After 1 second, the suit would catastrophically fail. A complete implosion. The force would transfer directly to your body. The air in your lungs would be compressed into nothing, and your ribcage would shatter. Your muscles would be pulverized, and blood vessels would rupture throughout your body. Your organs, subjected to this impossible squeeze, would simply shut down. Consciousness would be extinguished in an instant. Before your brain could even fully process the sensation of being crushed, it would be over. And that's only the pressure. If by some miracle of futuristic engineering, you had a suit that could withstand the weight of Venus's sky, the planet would kill you in another, equally horrific way. Venus is a runaway greenhouse, trapping heat better than any planet in the solar system. The surface temperature averages 465 degrees Celsius. That's hot enough to melt lead, zinc, and tin. Your state-of-the-art suit would become a convection oven. The cooling systems would be overwhelmed in seconds, and the heat would begin to cook you from the inside out. Your internal body temperature would skyrocket. Severe heat exhaustion would transition to fatal heat stroke in under a minute. Your proteins would denature, your brain and heart would fail. And what if your suit failed and you tried to take a breath? The atmosphere is 96% carbon dioxide. A single inhale would be instantly fatal, flooding your lungs with unbreathable, superheated gas. As if that weren't enough, the clouds above rain sulfuric acid. While it evaporates before reaching the ground, the vapor hangs in the air, a corrosive mist that would eat through your suit and burn your skin, pressure that crushes, heat that incinerates, and an atmosphere that suffocates and dissolves. Venus may look beautiful from the safety of space, but it is a world meticulously, almost intelligently, engineered to kill you. Welcome to a world of savage extremes, a planet that can freeze you solid and incinerate you within the same day. This is Mercury, and survival here is a matter of which side of the line you're standing on. As the closest planet to the Sun, Mercury is relentlessly bombarded by solar radiation nearly 7 times more intense than what reaches Earth, so you'd naturally expect it to be unbearably hot, a scorched wasteland across its entire surface. But that's only half the story. The key to Mercury's deadly duality is what it lacks. Mercury has almost no atmosphere, just a thin, transient exosphere. There's no blanket of gas to trap heat or distribute it across the planet. So when the long night falls, a night that lasts for 88 Earth days, all that solar energy radiates back into space. Temperatures plummet to a cryogenic minus 180 degrees Celsius. If you were to stand on the night side, your suit's insulation would initially protect you. At first you'd feel fine, witnessing a sky of brilliant, unwavering stars. But the relentless cold would begin its work, leaching heat from your suit. Soon, your fingers would go numb. Uncontrollable shivering would begin, your body's desperate attempt to generate warmth. As your core temperature drops, your muscles would stiffen, making movement a painful, sluggish effort. Confusion would set in. Your thoughts would slow, becoming disjointed and faint. Within an hour, severe hypothermia would shut your body down completely. But step just a few meters across the Terminator line into daylight, and Mercury becomes lethal in an entirely different way. Here, the surface temperature soars above 420 degrees Celsius, hot enough to melt lead and zinc, with no atmosphere to scatter or absorb the energy. The full, unfiltered fury of solar radiation hits you directly. Your suit's cooling systems would be pushed to their absolute limit. Your body would overheat almost immediately. If your suit's cooling failed for even a moment, catastrophic heat stroke would follow within minutes, leading to organ failure and death. On this world of brutal contrasts, Mercury doesn't kill you one way. It gives you options. Of all the hostile worlds in our solar system, Mars is the most deceptive. It's the planet that gives you hope, right before it takes it all away. From a distance, Mars feels tantalizingly familiar. Its day is just a little longer than ours. It has polar ice caps, vast canyons, and dormant volcanoes that dwarf any on Earth. Standing on its surface, you might even mistake the rust-colored plains for a terrestrial desert. It looks like a place humans could survive, a second home. But this comforting illusion is fragile, and it doesn't last. The first lethal truth is the air itself, or the lack of it. Mars's atmosphere is incredibly thin, less than 1% the pressure of Earth's, and it's almost entirely unbreathable carbon dioxide. Your suit is your entire world. If it suffered even a pinhole-sized breach, the pressure would escape with explosive force. In the near vacuum, the boiling point of your bodily fluids would plummet. Gases in your blood would begin to boil, a horrifying process called ebulism. Your skin would swell grotesquely as the water within it vaporized. Consciousness would vanish in seconds. Your body would fail completely within minutes. But even if your suit stayed perfectly intact, Mars has a more patient way to kill you. Dust storms, not the brief squalls of Earth, but colossal, planet-enveloping events that can rage for months, blotting out the sun. The dust is finer than sand, sharp, and electrostatically charged. It clings to everything. It would relentlessly work its way into every joint and seal of your suit, clogging vital air filters and jamming mechanisms. Your life support systems would slowly degrade, cutting off oxygen and heat regulation. Even your habitat wouldn't be a guaranteed sanctuary, as the abrasive particles wear down seals and contaminate life support. Mars doesn't always kill you with a sudden, violent act. Sometimes it just waits, letting its quiet, persistent hostility wear you down until there is nothing left. Why Jupiter would end you before you ever land? Jupiter has no solid surface. If you entered its atmosphere, you'd fall endlessly through violent storms and crushing pressure. Winds reach hundreds of kilometers per hour. Lightning here is powerful enough to power entire cities. One direct strike would disable your ship instantly. Power would fail, oxygen would fail, heat would drop. You wouldn't hit the ground. You'd be destroyed long before that. Why Saturn's beauty is a trap? Saturn's rings are stunning. They're also deadly. They're made of ice and rock moving at tens of thousands of kilometers per hour. A collision would tear a spacecraft apart instantly. And deep inside Saturn's atmosphere, pressure becomes so intense that hydrogen turns into liquid metal. Saturn is majestic and completely unforgiving. Why Uranus might turn you into a diamond? Uranus is one of the coldest planets in the solar system. Its atmosphere contains methane, which is toxic to humans. A small suit breach would be fatal within minutes. But deeper inside Uranus, pressure and heat become extreme. So extreme that carbon crystallizes into diamonds. The human body contains carbon. In theory, Uranus could compress you into something far more valuable than you were before. Deadly, but poetic. Why Neptune is the most violent place in the solar system? Neptune has the fastest winds ever recorded, over 2,000 kilometers per hour. These winds create massive vortices that can tear spacecraft apart. Inside them, extreme forces would crush your organs and pull blood away from your brain. You'd lose consciousness in seconds. Within minutes, both you and your ship would be ripped apart and absorbed into Neptune's atmosphere. Fast, violent, final. Why even Pluto can kill you? Pluto is small, quiet, distant, and brutally cold. Temperatures reach -239 degrees Celsius. A single failure in suit insulation would cause frostbite in seconds. Your blood would freeze. Your body temperature would collapse. Within minutes, you'd lose consciousness. Compared to the others, Pluto is almost gentle. Why the solar system isn't built for us? Every planet has its own way of killing you. Pressure, heat, cold, radiation, storms, vacuum. Earth isn't just rare, it's perfectly tuned. And the real question isn't why these planets are deadly. It's why this one isn't.